Hello, everyone. I'm AnilKumar from Toronto, Canada. Glad to see you all today. We are going to continue with our classes on advanced functions. We had been talking about reciprocal functions, correct? We have done polynomials. Are you all absolutely clear about reciprocal functions? Or do you have some doubts? Anybody? Any doubts? So, okay. So I'll assume that you all know. I'll begin today with kind of a review. So I have two questions for you. One is based on reciprocal function. The other one is on inequalities. Now, these two are very important concepts for moving forward. Next is rational functions, correct? So let me share with you the lesson which I have prepared. You all can see my screen, right? So I think you're all on mute, so I don't hear you.
Yes, sir, we can see the screen.
Okay, so this is a circle which I have shown you. Is circle a function?
No, sir.
Oh, no, it's not a function.
Not a function. It fails vertical line test. Now, what is the equation of circle?
X squared plus y squared equals r squared.
Perfect. How can you make it a function?
By restricting the domain, sir.
Okay, you are saying restricting a domain. That's good. Okay. Hamza, can you tell me how will you make this circle a function?
I was gonna say the same thing as Akshay.
Vishruta,
Restrict the domain.
Vishruta, what will you do say?
You could open up the circle.
Like what? Make semicircles, you mean, right? How will you do
Sir?
that? Yes.
Sir,
Wait. I know you're coming to the right. Yes. How will you open up a circle and make it a semicircle? Yes, tell me.
I think by creating space by transferring them each like
Okay.
1 unit.
Okay.
opposite
Ankita,
side.
I would like to have your thoughts on this.
I was going to say maybe identify, distinguish the asymptotes.
No, there are no asymptotes in circle.
Okay.
So, okay, let's get back to Akshat. How do I restrict so that this becomes a function, the circle?
Sir, I think I meant to say range, but I said domain instead. You can restrict
Correct.
the range.
Good, you said that. So
Yeah.
let us be very clear about it. See, we thought that we know all this, what we have learned. This is the very basic unit, correct? We know this is not a function because it crosses a vertical line at 2 points. Since it crosses the vertical line at 2 points, how could we restrict it? Well, we could restrict it if I could say, if I restrict the range, if I make range greater than equal to 0, or I could also make it less than equal to 0. In either case, it becomes a function because we are removing one of the half, correct? In that case, the vertical line will only touch the boundary of the circle at 1 point, and so it becomes a function. Perfect. So that is it. So we have this equation which is x squared plus y squared equals to r squared, and we have decided to keep y as greater than equal to 0. That really means we are now focusing on the top half of this circle. Is that clear to you? Because now you can see y is greater than equal to 0. Well, it will be restricted on the upper half because the value of r, that's fine, but at least we are only considering 1/2, which is called the semicircle, correct? And therefore, another very important function for us is semicircle itself. Now, okay, Hamza, how will you write this equation in terms of y equals to something as f of x? Can you isolate y and tell me what is the equation of semicircle now? So I want you to give me the equation of
Okay.
semicircle.
Okay, so you want it in terms of y equals to,
Yes.
okay. Okay, so y equals square root of x r plus x, I think.
No. Akshay, can you tell
I
me?
think I have to do it on paper. I can't tell you like this.
No. See the screen. Try to give me. Yes. Akshay, tell me. Y equals to what?
So when you're isolating for y, right, sir, you just move x squared to the other side, so it'd be negative x squared plus r squared.
Or we can write r square minus x square. You're right. Negative x square plus r square is a good option. Correct. Because we write x first. Correct?
Yeah.
Yes. That is also a good option. So, but we could write r square minus x square. And we will keep this positive since we are looking into y greater than equal to 0. So that means we are considering the top half of the circle, which is a semicircle. Correct? If I make y as less than equal to 0, it means the bottom half, right? Both are functions. I could take either one of them. In your test, expect this question. I am taking it exclusively for you because 90% chances are that you will get this question in your test. You should not mess it up there, right? So now we will see how do we sketch reciprocal of this semicircle. Is that clear to you? Semicircle is clear? Okay. Before I move forward, now tell me, what is the domain of this semicircle? Yes, Hamza, can you tell me domain of this semicircle? In terms of R.
Yeah. In terms of what?
R. Because it is
Uh,
R square minus X square, correct?
so it would be x of all real numbers. Did you forget that x of all real numbers? R, let me just think for a second. R is greater than or equal to 0. I think.
No, that is not working. Ankita,
It cannot equal 0 since it's in the square root.
no. Square root can be 0. No, that's not correct. The square root thing should always be positive. So we are looking for something. We are saying R square minus X square should be greater than or equal to 0, correct? It cannot be negative. So that is the inequality which you have to solve. Solve this inequality and tell me what should come here. We want to write what X should be, correct? Anybody? So let me take it on the other side. So R square is greater than or equal to X square. Now tell me, I'm saying X square is less than or equal to R square. Can you tell me the answer? What should I write here? X is what?
Sir,
Yes.
would it be x is less than or equal to the absolute value of r?
Very good. X is less than equal to absolute value of R because you're going to do square root at this stage, correct? When you do square root of X square, you get what? Absolute value. Do you see that? Correct? So we are looking into absolute value of R. It should be plus and minus R value. Is that okay? So that is what this is. So that becomes the domain of this particular function. Range. What is the range? Range is what? We'll just write range also, okay? Yes, anybody? Tell me range of this particular function. Y belongs to real numbers where what is the value of Y?
Greater than or equal to 0.
And less than what?
Less than or equal to the radius, sir.
Radius, correct? Because ultimately the maximum value is going to be the radius itself. Therefore, the range will be less than or equal to R, correct? So that becomes the domain range of your semicircle, absolutely clear in general. Now, this is very important because if I would have written there 25 or some number, it was easier for you to work it out, correct? But putting a value like R or a variable or something else makes it difficult. So that is very important to understand, correct? Okay, let's move forward. So what we were trying to do. Okay. Now we're trying to sketch the semicircle, right? How do we sketch the semicircle?
Sir,
Yes.
you can identify your vertical asymptotes first.
No, not the reciprocal function. Not the reciprocal function. First is semicircle, okay? Yeah, I think Mohammed is also joining us. So let him join. Hello, Mohammed, have you joined us?
Yes, hello.
Hello, hi. Good to see you after a long time.
Yeah,
Good. So, Mohammed, we are actually doing reciprocal functions. We just began with semicircle. So, listen to this lecture today. You might need help on this. So, later on, I'll teach you the basic concepts which the class which you missed. Okay. So don't worry about it. So now we are at the stage that we have this function f of x, which is square root of 25 minus x squared. I have put r as 5, correct? We had r square, so r square is 25, correct? So we have this particular function, which is a semicircle, because we are taking only the positive values, and the maximum value could be square root of 25, which is 5. Perfect. Now, first thing is you have to sketch the function, correct? So for the sketching the semicircle itself, or any function for that matter, it is good to take some points, right? Good points, so that you have 4 or 5 points, connect them and draw your curve. We know this equation is of a semicircle, so we have to connect the points to get a semicircle. Perfect. So these are good points for 25 minus x squared. I could take the value of x as minus 5. Oh, I wrote here, wait. I have to, when I take x value as minus 5, I do get 0 here, correct? I should write x comma f of x. I'm taking x values, writing f of x. If I put minus 4 here, minus 4 square will be 16, right, for x? And then what do I get? I get 3 for f of x, right? So I'm writing f of x values in green now. If I put minus 3, 25 minus 3 square, which is 9, will give you 16 square root. So that will be 4. If I substitute 0 here for x, in that case, we get square root of 25, which is 5. For 3, we'll get a value 4. For 4, we get 3. And for 5, we get a 0. Is it clear? So these are your f of x values. And the first ones which I've written here are x values. Is that okay?
I have a question.
Yes.
For the -4, how did you get 3 as your answer?
Okay. So f of -4 is equal to square root of 25 minus -4 whole square, which is square root of 25 minus 16, which is square root of 9, which is 3. Is that clear to you? So
Yeah.
substitute the x value, calculate. Is that clear?
Okay.
Well, I have took a very beautiful function. 5, 4, 3 is your right triangle, correct? So it gives very easy values. In the test, you might not get 25 minus x squared, maybe something else, correct? In that case, you may get radical values. Let's be very clear about it, right? So for today's lesson, I took very neat values. Perfect. This is the best example. Perfect. The idea is to understand the concept. Now, Mohammed, did you understand how I got the values of x and f of x, correct? Once you have these values, you can plot them on the graph, right? Minus 5, 0, you get the value, right? 3 and 4, you get another value. 0, 5, you get a value, minus, right? Plus values. Is that clear to you? Once you have these values, just connect them with a semicircle. So you got a semicircle. Perfect. As expected, the domain of this semicircle is from minus 5 to plus 5, and the range is from 0 to 5, both included. Correct? Now, we have to sketch the reciprocal. So let's get back to sketching the reciprocal. That means 1 over f of x, correct? Okay, Hamza, how will you sketch 1 over f of x when your function f of x is given to you, which in this case is a semicircle? Can you please go through the steps which we should follow to sketch a semicircle, reciprocal of this function? Yes, Hamza.
Can we just plug the values in and then just plot the points, or do you want it like the way we did
Your
last?
wish, your choice.
Okay, so 1 over f of x. So you already know the values, like, so you plug in the values for each one. So the first one was f of x equals -5. So it would be
0, but it is negative, correct? So if you do 1 over f of x, it will be infinitely large, correct?
Yeah.
But because it was coming from the negative side, right?
It will be negative. Yeah.
Oh, sorry, it is positive 0. Sorry, it is positive 0. I'm sorry. Wait. Minus 5 gave us 0, but this is positive, right? This is all positive. So we are getting everything on the positive side. All are positive. So reciprocal of 0 is infinity. So here you will approach infinity. Is that okay?
Yeah. Okay.
Similarly, on that end, also you will approach infinity, because we are doing 1 of 0, right?
Yeah.
I wanted to show that, but it's also positive side. So both will go to infinity. As far as the inside values are concerned, if you do reciprocal of 3, you will
It's
get
1
what?
over
1 over
3,
3.
1 over 3,
For
1
4,
over
you get
4.
1 over 4. For 5, this was actually 5, you get 1 over 5, and you get 1 over 4, and you get 1 over 3, correct?
Yeah.
So those are the values which you have to plot to get your reciprocal, correct? So if you go with the points, Hamza, this is what you're going to do, and then you will plot those points. This is 5, that is 1, 1, and so 1 over 5 will be very close to this point, correct? These values are very, very small. They're actually very, very close to this. Now, okay, Akshat, can you add something on this so that you can sketch a better reciprocal function?
Yes, sir. You mean in terms of plotting the points or just?
No. How will you approach? Finding points is one approach. Yes,
Yeah.
it is. But I think it
So-
is not a very good approach, since now you see the points are what? 1 over 3, 1 over 4, 1 over 5. Who is going to plot those points on this curve?
Right. So, sir, I think another
Yes.
efficient way would be identifying your asymptotes,
Correct.
which should be at your zeros. And then after you do that, sir.
So first
you can-
step, let's wait. First step, identify the zeros and their reciprocal will be the asymptote. So write down vertical asymptote is x equals to 5. And here write down vertical asymptote is x equals to minus 5. Is this clear to you?
Yeah.
Right? This is your first step to sketch. Don't waste your time in finding the reciprocal and the points. Let us be very clear about it. There is no point in calculating. This is rubbish. I know your teacher will say follow that method, not for such a function. Okay, not for such a function. Okay. So we have to do all the mistakes in the lesson when we are learning, not in the examination hall. That's the whole idea. Okay. First step, vertical asymptote. Second step, yes, Akshay, tell me.
Sir, so your horizontal asymptote would just be at 0. So we can draw that, and then we can draw lines.
There is no
to-
horizontal asymptote since the function is not going to infinity. So in this case, there is no horizontal asymptote. So let's write down bold. No horizontal asymptote because the function maximum is 5. So what is going to be the local minimum? 1 over 5. So go for 1 over 5, which is shown here. Do you see this point 1 over 5? That is
Yeah.
the correct point. So using this maxima, you find this point, which is local, in this case, absolute also minimum. Do you see that? Because for a maximum in a reciprocal, it becomes minimum, and for minimum, it becomes a maximum. Is that clear to you? Got it? Yeah. And then next step, what?
You can draw a line for y equals to 1, sir.
Very good. We do not have that point at all. Just draw a line y equals to 1. Do you see that y equals to 1? Then you get this point, which is called invariant point. This is called invariant. It is going to be same. So we got two invariant points, one on this side, the other one on that side. This is invariant. You get the idea? You will not get these points from the points which I have written here. That was a mistake which my students should not do. This is what, don't do this for sketching the reciprocal function. You get my idea?
Sir,
Why I
could you
have
just
written this? I don't want to see this in your test paper. If you are doing this, you lost 50% marks because you could not draw invariant point, correct? You lost 0.5 for invariant point. Okay, now next.
Sir,
I have
now
a
we
question.
can.
Yes,
Sorry.
yes. Ask a question.
To find the local minimum, is it just the reciprocal of the first point? Is that just how you find the local
Maximum.
minimum?
Yes, local maximum gives you local minimum. Very simple.
So the local maximum is just the reciprocal of the last point on the f of
No,
x.
you see, in the path, range maximum is 5 only, correct?
Yeah.
In this case, this is absolute maximum. So you will get absolute minimum. So the lowest value will be 1 over 5. Is that clear?
Okay.
Now,
yeah.
actually speaking, once you've done the vertical asymptote, you got the local minimum because that was your x-intercept, y-intercept also in this particular case. Y-intercept is a very good point. So what you need to do, you got the invariant point, just connect and draw your curve. You're done. You don't have to bother about the other points which we had been thinking about. After you sketch your curve, you may like to put those points, but they are not very much required. You get the idea? Is that clear to everyone?
Yeah.
So this is most important thing. Ankita, I would like you to read all the observations which are written here, please.
Sure. I was trying to ask a question before that. So
Yeah, sure.
before I
Ask.
before I read the observations, could you just show like how you did the invariant points once again, just so I'm not
Yes, very
confused
good.
next time?
I have drawn a line y equals to 1. Do you see this line y equals to 1? Thick. So on that line, wherever it intersects the curve, that is the invariant point. Is that okay? Let me add a page here and show you. So what we have actually is, let me just draw rough. Okay. Here we have a function, right? Semicircle. Is that clear to you? Now, let us say this is my line where this point is 1. Do you see that 1? Y value? Where is it crossing? That is invariant point. These two. Because what is reciprocal of 1? 1 over 1 is 1, correct? So those are your invariant points. And these, let me put them slightly away, are your vertical asymptotes. So I'm drawing this vertical asymptote here, correct? I'm drawing this vertical asymptote here. And then when I have to sketch the function, this value, I get the lowest here. I am moving with my invariant point and moving up. Do you see that? It has to be a smooth curve while moving. Do you see that curve now? That is your reciprocal of semicircle done. And I want to highlight definitely this point, and this point. 1 over 3, 1 over 4. Where is that 1 over 3, 1 over 4? This is very difficult to draw. But 1 over 5, which is the absolute minimum in this case, will be written. You get the idea? We have two vertical asymptotes, which is y equals to r in general, in this case 5, and y equals to minus 5, plus and minus. Correct? That also gives you domain and range. Can you not tell me the domain of this function? Reciprocal function, 1 over f of x. Tell me. Ankita, tell me domain of this function.
X equals to all real numbers such that it is equal or less than 1.
Domain. Not range. Domain, x values.
Sir,
Yes.
would it be
Oh,
5?
1 over 5. Okay.
No,
Yeah.
no, domain. Yes, Akshit, please tell.
Sir, would it be 5 and minus 5?
Between minus 5 and plus 5, not including those points, because we have a vertical
Oh,
asymptote.
okay.
Within the domain, the vertical asymptote will not be included. Is that clear? Range, tell me now, Ankita, tell me range. Why? Range.
Such that x is
Y is
or y is greater than, oh, it has to be in between.
greater than equal to what? Less than equal to what?
1.
1 over 5 is your absolute minimum, right? But it goes to
So would I-
infinity. And therefore, it will be only y greater than equal to 1 over 5. Is that clear to you? So you see it is going to infinity, correct? Correct?
Oh, so you're saying that, okay, so the 1 over 5 would be the lowest point.
Yeah,
And that's why y is greater than that.
correct. Equal to also. Equal to also. It is
Okay.
there on the curve. Don't miss. So greater than equal to,
Sir?
greater than, less than are very important things. It is a mistake if you do not write greater than equal to 1 over 5.
I have a question.
Yes,
I have a
please.
question. I was watching this thing yesterday, like a lesson. And most of the professors, like it was something about domain, and they were saying that like x over real numbers is basically equals to x going to infinity. Is that true or is that false?
No, again, your statement. X belongs to real number what?
They said x over real numbers is basically the same as x going to infinity. Is that true?
Yeah, x belongs to real number is all the numbers, right? So this
Yeah.
this is all real numbers along the x-axis, correct?
Okay.
In our case, We are restricted to this point, correct? Between
Yeah.
plus and minus 5. So we have to say that. For some polynomial, it is all real numbers, correct?
Mhm.
If I take x cube as my polynomial, there is no restriction at all. So I'll just write x belongs to real number. It depends on what function you're working. Now, is this absolutely clear?
Yeah.
To all, right? Good. So let's continue with this. Okay. So Ankita, I'd like you to read all this, please, from here.
Reciprocal of positive numbers, or yeah, is positive. Reciprocal of negative numbers is negative. Reciprocal of less than 1 is greater than 1. Reciprocal of greater than 1 is less than 1. Reciprocal of infinitely large number is extremely small. Reciprocal of infinitely small number is extremely large. Reciprocal of positive or negative 1 is same invariant.
Correct. Is that clear? That summarizes all the thoughts. So with that, let's move on to a neatly laid out answer here. So we have a semicircle right there, and then we have the reciprocal of the semicircle on the other side, correct? So what you see is function f of x here and 1 over f of x in this particular side. You can see this is all positive, and therefore the reciprocal is also all positive, correct? And where you have this particular point as an x-intercept, reciprocal is a vertical asymptote, correct? So the x-intercepts goes to a vertical asymptote, and you also can see a maximum here has now become a minimum here. Do you see that minimum maximum? Correct. So that is in general how you have to look at the points, and definitely this was too small, but there are invariant points where y is equal to 1, correct? In this case, perfect. So that is where we are going to end this particular session. Now, as I was saying, we could have any value. Instead of 25, we could have any value. So what you should do now is try out some other function. For example, 9 minus x squared, correct? Just try out some function. How do you sketch it, and how do you sketch its reciprocal? So that brings us to the end of reciprocal. Another very important topic which we had covered earlier is inequalities. Before moving forward, I want to make sure that you understand inequalities without any problem, because once we take up rational functions, then the inequalities are going to be even more difficult, correct? Rational function is the ratio of two polynomials. So we have to be very good in understanding the inequalities of polynomials, correct? Mohammed, since you had seen polynomials earlier, you understand. So I think now you can participate actively. So now we will actually summarize the steps of solving polynomial inequalities. Well, the steps are, first step is inverse operation, which I'm trying to say is, let us say we are working on this particular inequality, which is x cubed plus 3x squared minus 13x minus 7 is less than 8, correct? What should be the first step to solve this? Hamza, can you please tell me? You are on mute, Hamza.
Oh, sorry.
Yes.
Okay, so the first thing, I don't exactly remember what the first step was at Utah, but I think it was the like terms, combining them.
So we have this particular equation, x cubed plus 3x squared minus 13x minus 7 is less than 8. If you have to solve this inequality, how will you solve it? Just tell me that.
Oh yeah, so wasn't it you plug in values and see which one works? Is that what you did?
No, that is when you have a polynomial equal to 0, then you're trying to find the roots, correct? So you have to write it in that form, so what will you do? You have to bring this 8 to the left side so that you have less than equal to zeros on the other side.
Oh,
right?
yeah.
Then you
Okay.
work on the polynomial, correct? Mohammed, is this step clear to you? So when you're given this inequality, you will bring 8 to the left side. So we call this as an inverse operation. So just make 0 on either one of the two sides, correct? So that will be my first step. Once I bring 8 to this side, then I'll get this equation as x cubed plus 3x squared minus 13x minus 8 and 7, 15, correct? Is less than 0, correct? Now I have a polynomial on one side and 0 on the other side. It becomes simpler to solve this inequality, correct? Algebraically, we're solving it algebraically. So we are looking for algebraic solution. There could be graphical solution also, but we are looking into algebraic solution. Clear? Now, what do you need to do? What Hamza was saying. Now you have to factor it, correct? Applying the factor theorem. So you have to work out possible values which could give you a factor. So that is remainder theorem, right? So from remainder theorem, we know the 15 gives me possible values as plus minus 1, plus minus 3, plus minus 5, and plus minus 15. Since these are the factors of 15. So we'll try with what is the value of this polynomial for plus 1? Is it 0? What is the value of this polynomial for minus 1? Is it 0? Similarly, we'll test the other
I have
value.
a question.
Yes.
If I remember correctly, wasn't it two factors that multiply to 15, but then add to 13? Is that what you're trying to do?
That was quadratic equation. Now we are talking about polynomials. That product and sum was for quadratic equation, right? Not for
So what's the what's the difference?
lot of difference, because here product and sum, whose product and sum will you find? Let us say 15,
the product of 15,
but there are so
and
many
sum.
things in between, right?
Yeah.
You cannot do it.
Oh, okay.
Once you get to quadratic equation, then you do product and sum. But this is cubic. At this stage, we cannot do it.
Okay.
Right? So, so at this stage, we have to look for possible values of x, which will give us a 0. So you can put f of 1, for example, see what do you get. F of minus 1, for example, see what you get, right? And keep a track whether you're going from negative to positive or positive to negative. As soon as you hit a 0, then you have to divide, right? Then you have to do polynomial division, correct? It is a cubic equation. So once you divide, you'll get a quadratic equation, correct? So after cubic equation, you get a quadratic equation. Once you get a quadratic equation, then you could do product and sum and factor it further, or use quadratic formula to factor it further. Is that clear to you?
Sir, I just wanted to clarify something.
Yeah.
So the 4, we use these 4 factors, right? Just positive 1, negative 1, positive 3, negative 3, and those ones?
Yeah.
Okay.
Yeah. So how will you find the first 0, right? It is not given to you. You have to figure it out. Then you will divide and you'll do a synthetic division, which I have shown here. This is a synthetic division part, which I have shown, correct? You divide with whatever gives you 0. It seems minus 1 gives me 0. So then you do synthetic division, you get the quadratic factor. Once you get a quadratic factor, since it was a cubic equation, divided by a linear factor, you will get quadratic equation. Then you can do product and sum and find the other factors. So you have a factored form of your polynomial, correct? Once you have factored form of polynomial, you have to now work on the inequality that in this case, it is less than 0. Means if I multiply all the factors, I should get a negative value. That will be part of my solution. A cubic equation is expected to give you 3 real roots, right? They may be distinct or they may not be distinct. All 3 could be at 1 point, 2 points, 3 points, correct? Or they may be 2 imaginary, whatever. But at the most, 3 roots are expected. If you get 3 roots, which I think you get in this particular case, these 3 roots will divide the whole domain into 4 intervals, correct? So we will use this interval table analysis to find in which interval the function is negative, because we are interested in less than 0. Perfect. And so in these intervals, we'll take a test point, and at each test point, we'll check our factors, multiply them to figure out which interval is the part of solution. Is that clear to everyone? Correct? Now, once you get to the solution, there are many ways of writing the solution. You could show the solution on a number line, or you could also show it as an inequality, correct? Depending on what is being asked. So these are all the steps which we need to do. So I'm going to review all these steps one by one.
Sir, I have a question.
Yes.
So the solution, like the number line you drew down below, you'd need to find the answer first, right? So can you just—
Of course. Yeah.
Can you
The
show
first
the
page
answer?
gives you
I'm just trying
everything.
to
You have to
understand
first
the
find
number.
the answer. Yes.
Okay.
I've shown all these steps to find the answer. Now we will try to find the answer. Okay. Is that clear?
Okay.
So let's move on. Try to find the answer. So we have our equation here. So you have to guide me to find the answer. Fine. So we first step bring 8 there. So we have x cube plus Mohammed, you can join us now. And this is a good review. 13x minus 7 minus 8 is less than 0. So we get from here x cube plus 3x squared minus 13x minus 15 less than 0. So we'll try some values as we said plus 1 and minus 1, right? So if I try 1, what do I get? I'll put 1 for x. I get 1 plus 3 minus 30 minus 13 minus 15. And clearly this is not equal to 0, correct? Minus 2 heavy. So it is negative in a way, correct? Minus 13 minus 15, very big numbers. Now let me put p of minus 1. So if I put minus 1 cube will be minus 1. Here this will be, substitute minus 1 in your calculator, check the value. Here it will be 3. Minus 1 will give me plus 13 here. And minus 1, this is a constant. If you calculate this value, what do you get? Minus 1 and minus 15 is minus 16. And 3 and 13 is plus 16. So we get a 0, correct? So that means x minus 1 is a factor. Perfect. So now at this stage,
Sorry, I
we
have a
can do
question.
long division.
I have a question.
Yes.
So isn't the target of the inequality to find a number that's less than 0 or?
But
Great.
before that, you have to find the factors. Otherwise, how will you find it?
Okay. Oh, okay.
So you could now do long division or synthetic division. You know the first root, which is at x equals to minus 1, correct? Minus 1, correct? You have to find the other roots. The idea is that if it is a polynomial and this is leading coefficient, then the polynomial will be something like this, correct? So basically, if I find these roots, then we know that the solution should be what? Solution should be this side or this side. Do you see that? Because those are the negative parts. Is that clear to you? Is that clear? Are you all with me? Ankita, is everything clear to you at this stage?
Yes, sir, I'm following along.
Okay, now, what do you prefer, to do synthetic division or long division?
Honestly, sir, they both seem kind of like you're doing it, so it seems easy, but I feel like if I do more practice, then I would understand which one works better for me.
Okay. So, shortcut is synthetic, long division is easier, right? But you could do any, right? So it doesn't matter.
I feel like we should do long division. It's harder to go wrong that way, but I mean, synthetic division is also basically the same thing. So
Okay, let's do synthetic division.
Sure.
Hamza, help me. Write down the coefficient. We are dividing by minus 1 since we found that minus 1 gives us the first root, correct?
Yeah.
Let's write down the coefficient. Synthetic division is
Okay.
very simple, right?
So 1, 3, negative 13, and then it would be negative 15. Yeah.
Now tell me what to do next.
Yeah, take the 1 down, multiply by negative 1, and add the 3. Yeah. And then take the 2, multiply by negative 2, and then add the 13. And then take the negative 15, multiply by negative 1, and then add the negative 15, and you get 0.
Very easy, right? Very easy. Ankita,
Yeah.
do you see this? Practice synthetic division. It is very easy and very fast. Easy to check. Hamza is right there. Okay, now, what is your quadratic equation? X squared plus 2x, right? Minus 15. Can you factor this, Hamza? Minus 15 product, sum is 2.
More, okay. Yeah, you can. 5 and 3.
5 and 3. Simple as that. We already have one of the roots, which is x minus 1. So have we factored our cubic equation? We have, correct?
And then if you go back and check, we have x plus. Okay. So I think, yes, I think we did it right.
We did it right. So, Vishruta, is this clear to you?
Yes, sir, it's clear.
Mohammad, is it clear to you?
Yes.
Very good. So let's move on. So we have factored this particular equation. As I'm showing you here, we did all this, correct? So we brought the 8 to the left side. As you can now see the solution. And we got our polynomial on one side less than 0. That means we are looking for negative interval. Inequalities will give you a range of solution, not just a value. So now we need to factor this. So we tried f of 1, we got minus 24, f of minus 1 gave us 0. That means minus 1 is x plus 1 is the factor, correct? So that is our factor x plus 1. We can divide by minus 1. Synthetic division is shown here. We got the same result, and we know minus 15 sum and product, 5 times 3, 3 negative, 5 positive. So we got the other two factors. Now we have a factored form of our polynomial. It is very easy to write down the solution. Can you tell me the solution now, please? That is the factored form. How will you find the solution from here? Yes, Ankita, can you help me? From here, how do we get the solution of this particular inequality, which is given to us in factored form? Yes, Ankita. Okay, Hamza, can you tell me, how will you get the solution from this equation?
Sorry, so is this a step where you put it on, where you plot it on the number line to show the solution, or?
Well, first you have to find the solution, then you can plot this solution on the number line.
Oh, okay. X plus 3. Just plug it in and check. Is that? I
No,
think
no,
that's what I
no.
would do.
What values will you test? Vishruta, can you help me?
Oh, okay. So I would just
Yeah.
check the x. Can you check the x was 5 first?
No, 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 no. You cannot check individually. Ankita, do you want to give an attempt? How will you find the solution of this inequality? Can't hear you. Now you're on mute, but earlier, yeah, now, yeah. Your volume is low or what? Can't hear you. Okay, Vishruta, can you help us? We cannot hear Ankita, so sorry. Yes, Vishruta, yeah.
So you would write it as an inequality.
This is an inequality given to you, correct? How will you solve this inequality when given in factored form?
Oh, okay. I understand now. So would
Yeah,
you
tell
just
me.
plug in the x minus 1, or are you just plug in 1 and find it?
No,
So you
no.
found x minus 1 before, right? And then we just plug in 1 to see if it works.
What works? Whether it is no,
So you know you found
randomly.
x. So
Randomly
you know
we
you
cannot
found
plug.
x. No. So you know you found x minus 1. Like when we factored it and we found our solution. Would we just plug in? We just plug in 1 and see if it works.
We know f of 1 is minus 24. We got calculated. It is a part of solution, but how will you find the solution set? Okay. So from here, there are a couple of ways. There are two different ways in which we could do. One is graph and one is interval table. Vishruta, can you please explain me the interval table of finding this inequality? How will you do?
You get the answer by plugging in the numbers.
Which numbers? How will you create interval table?
First make a chart.
Yes,
with
chart. What will come in the chart? Tell me.
Or would it be the coefficients?
No. You have to write all the zeros. So
Wait.
zeros are at -5, -1, and 3, correct? These three zeros divide your domain into 4 intervals. This interval is from -infinity to -5. Then we have an interval from -5 to -1. We have an interval from -1 to 3 and from 3 to infinity. So 3 zeros will divide the whole interval into 4 different intervals. In each interval, we have to take a test point. So in this interval, I could take -6 as a test point. And the other interval, I could take -2, for example. Here, 0 is a good test point. I could take 4 as a test point in the next interval. Now, since we have the interval test points, now we can test all the factors or the function itself. So you could, at this stage, directly to the function or the factors. I prefer to write factors. So we'll test what is x plus 5, what is x plus 1, and x minus 3 for these values. If I plug in minus 6 here, we get negative. Minus 2, 0, and 4 will give me positive. For x minus 1, these two values give me negative. The other two gives me positive. X minus 3, we get these three values as negative, and the fourth one is positive. If you actually write down the factors in order, that means zeros are from left to right. In that case, very neatly, you will get positive and negative values as I have shown. There is no need to even calculate them, to be very frank with you. Okay, now 3 negatives means the function will be what? 3 negatives means a negative answer. 2 negative means when you multiply, you get positive. So these are the intervals which are negative, positive, negative, positive. We can very clearly see that the interval which gives us the positive values is this interval, correct? And this interval. And therefore, that becomes part of our solution. Do you remember this? How we did interval table? That is how you have to do the inequality using an interval table. Now, do you understand what we have done, Hamza, so far?
Not really. I don't remember this. When did we learn this?
Interval
I
table.
think I just
Ankita,
forgot. I forgot this.
Ankita, do you remember doing this interval table to solve inequalities? No? Okay, that means you have to review this particular thing. Now let me explain you once again so that you get this, okay? Mohammed, have a good look at it. So, first thing first, there are three factors, three linear factors. So these three linear factors are giving us 3 zeros. Do you understand those 3 zeros? X
I understand the domain. I understand the. I think I understand now. So basically, what you did is that you found 4 intervals from the So the infinity to 5, the -5 to -1, -1 to 3. Okay, and then you just put a random point in between those.
Not random point. We selected points within the interval. So between -5
Yeah, so in
minus
between.
infinity.
So between the intervals, random points between the intervals, right?
Yes.
And then after you tested to see.
For each factor,
For each factor, then you
positive or
plug
negative.
in the point to see. Okay.
And
And
then
what
when you
it
multiply
would
the
be,
three
right?
factors, you get either positive or negative. Once you get, now you are interested in inequality which says less than, correct? Less than 0 means negative. That means this is your right solution, correct?
Mm-hmm.
Can you write down the answer? What will be the answer now? Tell me.
I think it will be x minus 5 and then x.
Answer, solution. What is the solution of this inequality? Anybody? Ankita, will you like to try? What is the solution now? You are on mute. I think your speaker is not working. Vishruta, can you tell me what is the solution now?
So we got that it's the negative one, so we write 5 and 3. Those are the ones that
So
we
less
include
than-
in our solution.
We'll say x is less than -5, correct? It's on the left side. Union, or you can use the word or. X is between -1 and 3. Is that okay? So that becomes the solution when you write in terms of inequality. Is that clear? If you want to put that solution on a number line, you can put that also on a number line. Now, here, I would like to show you one more thing, which is we already have a polynomial. So let me just, this is the polynomial.
Can you just scroll up and show me the number line really quick? Just
No,
want to see.
okay, number line I have not drawn here. I'll just draw it.
Okay.
So the number line solution will be left side of -5, -5 not being included, and from -1 to 3, correct? 0 will be a part of solution.
Okay.
Okay. Now, you could do one more thing here. This is a polynomial, leading coefficient is positive, and therefore, I could actually sketch a polynomial going through the, let's say these are my zeros, right? These are my 3 zeros, correct? 1, 2, and 3. Since the leading coefficient is positive, I have a graph of a polynomial which will be like this. You can see from the graph that it is positive in the area and is negative here. Do you see the negative portion? And this negative portion is the part of solution. So even without doing the interval table, you could actually sketch a graph here of the polynomial and get your work done. Write down the answer. If the question specifies do it with interval method, you have to show the table and the calculations. Calculations are important because now we'll be learning other functions, rational functions and some other, where graphing is very difficult. For polynomial, graph is easy, you could do that, but not for other. And therefore, you have to understand how do we solve inequality using this table. Is that clear to you all? Let me take you to a fresh page. We just did all this. What I was trying to say here is something like this. We did get zeros here. The zeros were at, as I said, -1. Then we had 1 0 at 3, 1 0 at -5. And this is a polynomial with leading coefficient. So I should say positive leading coefficient. That becomes your graph, correct? So where is it negative? We want less than. So that means it is on this side. So let me now draw the inequality solution is this. On a number line, if I have to draw, I will say this, correct? And of course, since it is less than, this point is not included. So you'll put a hole here. Is it clear to you? So that becomes a part of solution. Here is a quick look at the table which I have just done for you. So once again, we found the zeros. Zeros were at x equals to -5. That gives me 0 for this factor. X equals to -1. It gives me 0 for the next factor, x plus 1. And x equals to +3 is a 0 for x minus 3. We're looking for negative values. So intervals were 4 intervals defined with these zeros. We took test points which are within the intervals, and then we tested each of our factor, whether they are negative or positive. The function, multiply the factors. Odd number of negative factors will give you negative. Even number of negative factors will give you positive. So we are only counting odd or even number of multiple of negative factors. Odd will give me odd, which is negative. It is a part of solution because we are looking for a less than 0 value, correct? The other one positive, 2 negative gives me positive. It is not a part of my solution. The third one, 2 positives and 1 negative gives me negative. It is a part of my solution. The fourth one, all positive, is not a part of my solution. Therefore, I get a solution x is less than -5 or x is between -1 and 3. Is that clear to you? The same solution can be placed on a number line. And so I'm just taking you there. That is how you could actually show the solution on a number line. Is that clear? Here is the graph for this particular polynomial. As you can see, these are the 3 zeros, and the part of solution is within this portion and beyond this portion to the left. Is that clear to you? So that is how you're going to solve the inequalities. Okay? We are going to end our lesson here, but at this stage, I want to say that you need to practice a lot this chapter on inequalities. And
I knew everything, but I completely forgot the interval tables. I don't remember.
Okay. In case you have any difficulties, do let me know, because in the next class, otherwise, I'm going to start rational functions. Okay?
Okay.
Fine. We'll end our class here, and I'd like you to kind of wind up and tell me today's, like, in short, what did you learn? So shall we begin with Hamza? Hamza, can you tell me what did you learn today?
Before this, I never used the interval function and the table to ever graph a polynomial. I only really did synthetic division, long division. I just found it from there. So I think that was something new I learned in the interval table.
Okay.
It was a little difficult too.
Okay. Mohammed, how about you?
What do you call it? The interval table was the only thing I really understood, because we actually did that. Like, that was one of the last things we did.
Mm-hmm.
But yeah, everything else, like, it's kind of new. So
yeah, you missed a couple of classes. That's okay. Ankita? Okay, we can't listen to you. Vishruta?
It was nice to see like everything that we learned during like this course come to like together to solve one question, like
Mhm.
with all the factoring, the polynomials, and the reciprocal functions and everything. And then the interval table, I've done it a few times, but it takes practice to like start it up.
Correct.
Yeah, this was a helpful class.
So practice and then it'll be good. Okay. So moving forward, we are getting into some very difficult, rational function is the ratio of two polynomial functions, right? So a polynomial function is very simple as compared to rational function. So master these techniques so it's easier to move forward. Is that okay? So we'll end our class here. All the best. Thank you.